Okay, so for this example, we will conclude the arithmetic operations and with the use of the CMath library so that we can find the sine and cosine of an angle entered in degrees. So this will give us an opportunity to build a small application for conversion and of angles in degrees into radians, since the cosine and sine functions, as defined in the CMath library, can only handle as an input an angle supplied in radians. So let me save this file here. As you can see, this is our basic strategy, how we're going to tackle this particular application. So the objective is to create trig functions from CMath. Step 1 will ask the user to enter an angle in degrees. Step 2 will convert that angle to radians. Step 3, we will find the cosine of the angle using the radian values. And then step 4, we'll find the sine of the angle using the radian values. Okay? And then we'll combine the printing of the resulting values from the cosine and sine functions as our last fifth step out to the console or to the screen. So your typical breakdown within the function main, as you can see here, we're going to have a declaration block, an assignment block, a processing block, an output block to conclude pretty much what the program will do. And then the final or ending block, we've defined it as hold the screen so that the output will remain on the screen. And then when done, when you press any key to continue, that is, you can return 0 back to the operating system to let the operating system know that this process or this application or this program ran properly to the last instruction without any issues. So let's get started. First, one good idea is to have a look at the CMath library, right, from the standard library, and look at what functions you can use. Well, we know we need to do cosine and sine. So I'm going to go down here and look for trig functions right here. As you can see, you have a sine function, okay? And you have a cosine function. Now you have different flavors of it as well, right? For float and long floats here. But these are supported by C11 and higher, okay? We're just plain and simple looking at sine and cosine. Let's look at it quickly. Let me click on sine here. As you can see, in itself, it takes a float value and returns a float, okay? So the thing about it, though, is that the angle or the argument that it will accept has to be in radians, has to be measured in radians. Now, let's suppose you're on a construction site and you had to report an angle of 40 degrees so that the woodworker will go ahead and cut a piece accordingly. Now, they will understand what 40 degrees looks like because their tools are going to be calibrated for degrees. Should you express it in radians, you might throw off a wrench in the process, right? So unless they know radians. Now, unfortunately, sine and cosine and tan and all these functions here will only accept the angles measured in radians. So that means when you supply an angle in degrees, you're going to have to do some intermediary process in between by converting the angle into radians before you supply it to the function. So this is why I have another link here that shows how to convert from degrees to radians. So notice that 1 degree times pi divided by 180 is some value in radians. Okay? All right, so the formula is simple. So you're on the left-hand side, you're going to put in the actual degrees value multiplied by pi divided by 180. You will get back the radian equivalent to that angle in degrees. So for example, this converter here is an actual application that someone wrote and probably in JavaScript and put it in here. So if I had my 45 degrees, then 45 degrees, as you can see, is 0.785, depending how much precision you want, radians, right? So you could round it up to 0.8 radians if you wanted to do that, if you wanted to stay at 1 decimal point, okay? So that's basically the formula. So I'm going to keep that. We're going to use this formula for our intermediate conversion from degrees to radians before we actually solve for cosine and sine. So the key now is, what are the things we're going to need for our program? Well, we definitely need CMath, so we will have access to sine and cosine. I'm going to also need IOmanip, so I can round it up to 1 or 2 decimal points, the results. And at the same time, I need IOstream, so I can write a program that uses the keyboard and the screen for an interactive runtime program. So if it's an interactive runtime program, it's going to ask the user to enter an angle in degrees. So that's your main input. Then we need an intermediate variable that will hold a value of that angle in radians. So we need to convert it. We could store it back in the same angle, okay? Or we could have a separate variables. One remains in degrees, the other one will be in radians. So as you can see here, before I write my first line of code, you need to have a strategy. Okay? We know we're on step 2. We need to convert an angle to radian, an angle that was entered in degrees. Okay? So right there and then, that might dictate how many variables you're going to need, at least for that part. Then you need a variable for each output, maybe one for the cosine and one for the sine. Okay? And again, it all depends if you're going to reuse these values again downstream. If not, you could have simply a variable called result, and you just write over it every time you recalculate. So I'm going to do this version where it's very efficient. So I simply have a result, and I'm going to modify result every time. Okay? So let's do that. So I'm going to have an input. So I'm going to have double angle. Okay? And maybe right here, result. We could do it this way. Unless you, like I said, you want a result for cosine and a result for sine and a result for the angle in radians. Take it back. Let me break it down into its simplest form. So let's say we call this one angle in degrees, comma, angle underscore in radians, comma, okay, and result for cosine and result for sine. Okay, so this will be the safest way to do it initially. It uses a lot of variables. It will eat up some memory, which is not a big deal for this program. Is there a much more and a better efficient way to do it? Again, yes, it all depends if you're going to reuse these variables at all. If you're not, then there is a better way to do this. If you are going to use these results somewhere else, then this is the way to go and be safe. So let's say with safe mode, and I'm going to recreate this program where we're going to make it a little more efficient. But first, let's make sure that all of these variables get populated, and we go step by step. So first, you're going to ask the user, cout, enter an angle in degrees. Okay? That would be typically the natural way someone will enter an angle. So cn, and you're going to enter that to the angle in degrees. Okay? And that's it as far as the assignment is concerned. Now we've got a whole bunch of processing to do. We need the angle in radian before we find the result for the cosine and the result for sine. Okay? So, remember the angle in radian. And let me pull out the formula here. Is your angle in degrees times pi divided by 180. Now, you could make pi part of your formula, or you could have a constant called pi and reuse it. Okay? We've seen that before, so you could actually have a const double pi equals 3.14. Okay? So we have our own variable or constant called pi. So we could use that. Okay? And again, look at the formula. We're going to multiply the angle in degrees by pi and then divide the whole thing by 180. That will give us the angle in radians. So the angle in radian is going to be equal to the angle in degrees times pi. And just to be clear, let me put a parenthesis here. So this is for clarity. You're multiplying these two items and you're dividing by 180. Now this is important here. 180 is an integer. This is not an integer division, so no worries here because pi itself is not an integer. And the angle in degrees is not an integer since you're declaring them as double. The result of such an operation is a float. In our case, we've declared angle rad as a double. So this wouldn't be a problem. Okay. Sometimes it's good to avoid integer division. Sometimes it has a purpose. Again, we get to see that in further examples as we move forward with our lessons. So now we should have the angle in radian. So what do we do with it? Well, we're going to have to feed that angle in radians to the cosine and sine. Aha. So the result in cosine is going to be equal to the cosine function that's in the CMath and supply it the angle in radian. That's how it works. That's it. It's that simple. You basically, the cosine that you're seeing here is a function. Where was it defined? Let's go back here. That is, or like this sign here. Let me just back up and go to cosine this time. Right? The cosine is a function that takes a single argument of type float and it will return a float. And that is, or float, basically our double data type is a float. So basically it will accept an angle in radian and will return the result to res cosine, right? Res cosine is basically result for the cosine operation. So can we do the same thing for res sine? Absolutely. So that would be sine angle in rad. Semicolon. That's it. That is pretty much the heart of your program right here. Okay? These would have accomplished what you need in terms of processing. The final accomplishment that you need to have is to actually display the result so the user can make a meaning out of this program. What was the purpose of having this application? Is to supply an angle in degrees, and it will give you the cosine and sine of that angle. Okay, so now we can format our output, and then you could say the cosine equals, and then you could do something like this, res cosine. And then what I'm going to do is put a slash n, give me a new line, and I'm stay within the same stream. And then the sine equals of the angle. And that would be res sine. And then end the program right here, or end that line, that is. Now let's see how this works. So now is a good time to compile and run. There you have it. And it's asked me to enter an angle in degrees. But before that, let me just make sure we have a larger font here so you can actually see the work. I'm going to go to about 36 is fine. There you go. All right. Now, just to test it out, we know if we picked 45 degrees, for example, then the sine and cosines are going to be equal, right? Remember a little bit of trig? So let's try that, 45. Let's see if we get that. And sure enough, we do, right? Cosine of 45 degrees is 0.7. Sine of 45 degrees is 0.7. Now, let me write the output a little better so it's not as confusing. Let's do this. Cosine of, and then enter the angle in degrees. Something like this. In deg, and then equals something like this. This will show the cosine of the angle in degrees equal to this result. We're going to do the same thing here, right? So I'm going to copy this part right here and insert it right here. Okay, so what this is going to do again, it's going to show cosine of, so let me just write down of, whatever that angle in degrees is, equals that value. So let's recompile and run. Less confusing as far as an output is concerned, right? So let's enter our 45 degrees again. Cosine of 45, as you can see now, equals 0.7. So this way you can always have a reference as to what angle did you enter. All right, let's do 0 degrees. Can you guess what the results might be? Right? So we're going to go for an extreme, so you can run now. You don't need to compile anymore. And let's put 0 degrees. Okay? One is 1 and the other one is 0. All right, well, let's do 90 degrees. So let's go ahead and run again. And this should be flipped, right? So notice here that it's not exactly 0, right? It tends towards it. But could we round it up? Could we round it up to 1 decimal point? The answer is yes. So remember, we've done that before. So we could actually put a rounding right here. So fixed, set precision to 1. And this will apply for the whole cout stream. So now let's do this again. Compile and run. Now again, you have to compile this time since I made changes to the code, right? Let's enter 45 degrees again. Notice it rounds it up to 1 decimal point, okay? 0.7, okay? Let's go ahead and run this time and do our 90 degrees. And notice it rounds it up to 1 decimal point as well. So you can make adjustments of this nature. Great. Now, as promised, I'm going to rewrite this code where I'm going to be a little more efficient in terms of how to handle the intermediate variable. Okay? So what I'm going to do is I'm going to cheat a little bit. I'm going to copy this whole program and make some tweaks to it. Now, I don't want to tweak this one. I want to keep it original. Right? Some of you might be asking me later on for all the source code that we've been writing up so you can actually compare your code other than just what you watch on the video, right? So we're going to call this one example 16, and I'm going to save it as such. As you can see, for this introduction to C++, we've got 16 examples so far. Let me just make sure I spell example correctly. So we have example 16 for this one. And what I'm going to have is basically, I'm going to make this a little more efficient. Let's call angle. Notice I removed the angle degrees and the angle radians. Okay? And let's redo everything here. And basically, I'm going to ask for the angle like this. Now, we know this angle is in degrees. Now, what you could do is you can take that angle, and it's going to be equal to its previous value angle times pi me just separate things up a little bit, and then let me put my parentheses and divide everything by 180. Okay? Now, how about my results? Well, I could simply result. Right? So notice here, I'm trying to be as efficient as possible. So if you're going to do something like this, you could probably process the during the output. Okay? And so you could do something like this. You could do Cout cosine of the angle is, and then basically write the equation for cosine right here, cosine, and then supply the angle. So you could do the math right here, right? That's you call the function cosine that actually exists in CMath right here in the print section. And then give me a new line, /n. And then we're going to do the same thing here. Sine of the angle is, and then we could do sine and re-enter that same angle. And then do an end out. Now let's see how this behaves. So I'm going to compile and run. As you can see here, every time I'll have to change the properties here, so this looks a little larger for us to see. And let's enter that 45 degrees of us that we know. And sure enough, we get the right results. So we get cosine of the angle is 0.7, sine of the angle is 0.7. So without getting into the details of, again, setting the precision and what have you, you can see that I've used a lot less variables to solve the same problem. Now, this could be critical in case you are mandated to write efficient code where some of these variables are not going to be used anywhere else, and you just don't want to be too wordy. As you can see here on this version, there are a lot of variables. But it makes it easier later on if you want to reuse these variables like I did here, right? Here, right, it's a minimalist form of writing code. The results are still going to be valid, okay? Very good. So I hope this concludes this series of arithmetic operations. And stay tuned for the next series that I will be publishing soon. Thank you.